Okay, lastly here we want to describe what are outliers, right? We talk a lot about outliers, and you'll hear me talk a lot more about outliers, and it's just the effect they have, right? So I can't be quiet about them because they're just very important. So try to drill that thought into your head. And so talking about here, a box plot is a distribution plot, a very simple distribution plot that is really meant to focus specifically on outliers. So what a box plot is the middle box right here, we call it the mid-range of the data. It goes from the 25th to the 75th percentile. And then 1.5 times that would be where the whisker ends. So 1.5, this interquartile distance, this mid-range right here, 1.5 times that is where the whisker will go out to. And anything beyond that is considered an outlier in the classical definition of outliers, which is a really good reason. It's good to stick to the classical definition because the way that you manage or the way you truncate or kind of massage your outliers, dropping them, it will have an effect on your final statistic. So I know that you can manipulate your final statistic by the way that you know, many acceptable ways to truncate your outliers. So I prefer that people stick to this classical definition so that I know there was no kind of funny business going on. You're really just you're being unbiased in your data analysis and you're doing what's generally accepted as a good way to truncate your outliers. And so it's going to go 25th to 75th percentile, and then that middle 50%, 1.5 times that will be our threshold for considering something as an outlier. Again, you don't have to use this. If you skew from this definition, you just want to make sure you have a justifiable reason as to why you would skew from the classical definition. Maybe you have a very good reason. It's just you would want supporting evidence as to why. Okay.